My name is Kishan Ramaswamy. I'm from the product management team. I run product management for our VeloCloud product. And I'm very happy, very thrilled, and very excited to have Ed Fox here join me. I've done a few sessions with Ed, and I can tell you I've learned a lot from Ed. And it's got a wide range of knowledge, which I'm happy that he'll be able to share with you all as well. So as you see from the topic today, we've seen trends in the industry, particularly around fixed wireless and satellite. We've seen that boom quite a bit. So we just wanted to kind of introduce to you a few things that we've seen in the industry, what Ed's been doing, as well as how VeloCloud works with a fixed wireless technology. So that's us. Now, before we get straight into that part of it, standard disclaimer. I'm sure you all know about the disclaimers by now, so we'll skip through that. We wanted to talk to you a little bit more about something that's very core to everything that we do in what is called our software-defined edge division within Broadcom. What is the software-defined edge? It's actually three very distinct yet very integrated set of products and technologies. Right at the bottom layer, you've got the network layer. Very apt to what we're talking about today in terms of the different types of connections that are out there, which includes 5G and satellite. But in order for telcos to run these networks, in order for them to modernize their environment, the right capability needs to be there, which is what we provide, which is the platform on which they can modernize that entire infrastructure. So we provide what is called a telco cloud platform, which is the core, where you run a lot of the core services. We allow you to virtualize and run that. We also have the telco cloud platform for the radio access network. So ties back in very much to that 5G deployment. On top of that, you have the overlay networks. So those of you very familiar, this is our SD-WAN service. How many of you are here familiar with our SD-WAN technology? A lot of you with VeloCloud. Excellent, that's great. So you're all very familiar with what we do on the SD-WAN side, but we don't stop there. Beyond the SD-WAN product, we also have our software-defined access technology, SOTA for short. This is our remote access capability. You deploy that on your work issued or your personal devices and have secure connectivity between that client, that device, back to your corporate resources. And then lastly, we also have VeloCloud SASE secured by Symantec. That's part of this portfolio now, right? And finally, you have where the applications themselves reside. Traditionally, applications have been accessed from data centers, limited set of data centers, or more from cloud. But in a world where timing is everything, decisions have to be made quickly, you want to be able to have a stack that can basically run edge applications where you can access that application, inference, get the result, and execute on that. All of that is made possible through our edge compute stack. So like I said, three distinct products, but they all come together. So think about, I want to be able to deploy in retail, in healthcare, in manufacturing, a core set of platform, applications. I have a distributed environment through ECS. I can provide security, connectivity through the overlay. And right at the bottom is those underlay circuits that I basically bring in. So the entire stack basically comes together. We have intelligence that's basically built into each and every one of this stack. And the best way to basically consume or think about this is that three-layered cookie. You have that one cookie where you basically take the bite of that entire cookie. So that's our edge compute stack with the overlay as well as the underlay. That's SDE in a nutshell. Okay, now let's get back into core of what we were going to cover today. We're going to cover, obviously, our SD-WAN solution overview, but given the raise of hands that I just saw a minute ago, I think I'm going to just literally skip through that slide. We'll talk about the different wireless transport options that are out there, how they've evolved. We'll also cover the enhanced connectivity that Mettel basically brings in, and then what are some of the quality improvements VeloCloud brings in within that space. So this is kind of the high-level agenda. So again, you've told me you all are very familiar with VeloCloud. I'll just make 2 points over here. The conversation today is going to be more focused around the latter two, cellular and satellite types of connectivity. That's really the key part of this. What are we doing in that space? And second, that's not really coming out clearly here, but I do want to highlight, is that integration with third-party SSC vendors as well. I just want you to reiterate that message in the sense, while we have connectivity to our own SASE, and we provide that under one umbrella, security is a choice of end customers. They dictate what they want to deploy, and we give you the framework. We've built an automation in our orchestrator for the SD-WAN network to connect to third-party SSCs as well. So that's really what that core is. Okay, with that, I want to introduce Ed to basically walk us through what Ed's seeing in the field of fixed wireless and satellite.
Thank you. Good morning, everyone. Thanks, Kishan. It's always great to be on stage with you. It's always a lot of fun. I like when we do panels together more, actually. So I'm Ed Fox. I'm CTO of Mettel. I've been at Mettel I'm in my 25th year now. I've been in the industry for my entire life, basically. It's all Al Gore's fault for building the information superhighway all by himself when I was in college. So Mettel is a communication solutions provider. We're about 800 employees today. We operate globally. We only really hunt for customers in North America, but we provide a plethora of communication services from, believe it or not, still a lot of POTS lines, all the way up through thousands of locations of WAN. We also have a pretty huge mobility practice, which I'll talk about a little bit as well. We are a Gartner leader. For someone that's a smaller company like us, that's pretty impressive for us, and a lot of it has to do with our partnership with VeloCloud, going on a little over 9 years at this point. So that's allowed us to get into the managed network services Magic Quadrant. A few things there that I'll call out. We started on our AI and machine learning journey probably in 2017. And in the background, we've built a pretty extensive, what we call an IPA engine, Intelligent Process Automation. And it was all built around the information that we could get from the VCO, or now VECO. And we were able to be very proactive in our monitoring and build, for the lack of a better term, bots that actually will go out, interrogate the SD-WAN network, interrogate the rest of our network, and actually provide information to analysts. So there's some years where we've actually made our analysts, particularly in troubleshooting SD-WAN incidents, 82% more effective. So the ability to handle actually 82% more volume, just because they didn't have to waste 38 minutes on every incident doing triage and research. So we're pretty proud of that, and it all started with our relationship with VeloCloud. So today, Kishan asked me to focus on fixed wireless access and satellite. Here's an example of a location in the VECO. Just came across this one as we were preparing for this. This is one of our customers that's located in Florida. They are a construction company, concrete plant, so kind of in the middle of nowhere. They're not going to get any good wired terrestrial broadband, and we actually turn them up on the fixed wireless access. So we have. I'll talk a little bit more about the fixed wireless access, but we have a big fixed wireless access practice. And we started working with satellite providers a good 4 or 5 years ago, and I'll talk about that, how we got to where we are today, and I'll thank Elon. But you can see here in our Starlink measurements here, I think you probably can't see it, but it's getting about 225 meg down and about 30 meg up, with, believe it or not, a 19 millisecond latency. Which kind of blows away the fixed wireless access side. The big thing to keep in your mind, and when we do these, we have hundreds of customers in the same exact configuration scenario. It's not necessarily the latency that becomes the problem when the SD-WAN's not involved, it's the jitter. And it's the ability to remediate the jitter that actually allows us to provide, this company right here does a ton of SIP services over this network, believe it or not. And when the Starlink has a problem, it still works over that red QoE on the bottom, which is super impressive for the technology itself. On our fixed wireless access side, we're a wholesaler. We call ourselves an MVNO, but we're kind of a wholesaler on this side. We've built our network into all the MNOs, so AT&T, T-Mobile, Verizon, so we can actually affect a Mettel-owned IP address on a fixed wireless access point at a customer location. What that allows us to do is get around those bottlenecks of best effort fixed wireless access internet service. So it's allowed us to build a pretty robust fixed wireless access network that our SD-WAN customers get to enjoy. We also have a product, and I'll talk about this a little bit more in depth, called single SIM. That allows us to put multiple carrier IMSIs on one SIM, and that SIM will actually roam between different carriers depending on different algorithms. When we sell it, our salespeople say it'll go to the best carrier at the best time. The technical folks know it's not always that easy, but it does work very well. So that's something we will deploy fixed wireless access. We kind of do it more for IoT deployments when our devices only have a single SIM. On most of our fixed wireless access deployments, we'll put two SIMs in and we'll do some monitoring and we'll affect a changeover between carriers if there's a problem. On the satellite side, I mentioned we've been working with satellite providers for a good 5 years now. We've struggled, so when we provide our SD-WAN service, we do a fully managed network, so we will fulfill all the services, so whether that be broadband or Ethernet or fixed wireless access or satellite, whatever it is, we want to be the one throat to choke, pack to pat. And we provide that as a full service. So we were always looking for alternative methods that would provide business disaster tolerance. And we struggled with the SD-WAN providers, with the satellite providers over SD-WAN. A lot of TCP manipulation and a lot of aggregation of packets never worked really well with SD-WAN. And about 2 years ago, we started working with Starlink. It was actually part of our, one of our federal agency customers actually got early access to Starlink because of the SpaceX NASA contract. And we were able to start testing it. And from day one, it became a game changer, even when their constellation wasn't as big as it is now. Just a little bit as to why it matters. Some of you may or may not be aware, but there's different orbits above the Earth that communication satellites run in. Not many of them are high Earth. That's kind of like the elliptical orbit that comes around every once in a while around the Earth. Geostationaries, what is it, 22,000 miles up. But that, you know, that you can, with 3 or 4 satellites, you can cover the Earth. But it's a very crowded space today because everyone wants to get in that space, and there's not a lot of, it's right over the equator, and it's got to be 22,000 miles. So you have to actually apply for space in geostationary. MEO's pretty much, it's dominated by DoD and other, what I'll say, when it's ours, it's great. When it's another country's, it's nefarious. But a couple MEOs are trying communication, internet broadband services. And then LEO is where all the money's going now. And it's what Starlink has, or actually SpaceX has lit a fire under, no pun intended. And to cover the Earth, it just takes a lot more, you know, I think Starlink's constellation is 342-ish miles above the Earth. Those things travel at 17,000 miles an hour. So if you think, I'll have a better slide on this later, but those satellites are going at 17,500 miles an hour. They're only in view of from horizon to horizon for 90 seconds. So to have an SD-WAN box on the edge that remediates all that stuff is super important. I talked a little bit about the different internet service providers. Clearly, you can see SpaceX and Starlink have driven this market. I'll talk a little bit about why, but that's how we ended up choosing them. I was very cautious with the speeds that I put up here. As you saw when I showed it in real time, we were getting much more than what SpaceX actually commits to. But today, their constellation is, it's almost 6,500 satellites today in low Earth orbit, and growing like crazy. I think, I'll show it in a little bit, but I think they averaged a launch every 5 days in 2024 into June. So pretty amazing. Who do I have there next? OneWeb is the next closest, Leo. We're actually working closely with VeloCloud and VMware and OneWeb as an alternate provider. They are focused only on business, and they have about 650 satellites in LEO orbit. They're a little higher up than the Starlinks are, so a little bit more latency. But with with SD-WAN overlay, it makes it easy to deploy. So we will be partnering with them. We just have a pretty massive commitment to Elon at this point. And you can see the rest. There's a lot that have tried. And if you want to go to spacenews.com and watch what's happening in this space, it is another pun not intended. There's so much happening in this industry right now. There's so much money pouring into LEO communications, and we won't get into it here, but it's also becoming, there's the FCC just named it supplemental space coverage or supplemental coverage from space. It's now a regulated part of the cellular network. So I don't know if you read about SpaceX actually broadcasting T-Mobile's frequencies, and Verizon and AT&T had different providers that they were partnered with up here, but they both just made massive investments in a company called AST Space Mobile, and they're going to allow Space Mobile to broadcast their frequencies from low Earth orbit. So interesting. And the two really interesting factors here are, I didn't mention yet, but I have Amazon Kuiper up there, Project Kuiper. They've fallen behind because they are one of the two, SpaceX, Starlink, and Amazon are one of the two vertically integrated companies. So what I mean by that is they make their own satellites, they launch their own satellites, and they provide their own internet broadband service through those satellites. They are the only two companies that do that today. Amazon's not there yet. They've had some issues with some of their rockets earlier on, and I think Jeff Bezos is more interested in doing entertainment flights than he is actually chasing after Elon. But they're the only two integrated ones. Everyone else has to, if they're the service provider, they go out to someone else to build their satellites, and then they all now go to SpaceX to actually get launched. So it's pretty interesting. This is back from May timeframe, actually, and SpaceX had done a total of 346 launches, 52 this year. Actually, a pretty cool fact is that until SpaceX actually did their Dragon capsule, the United States had not put up an American from American soil into space since 2006, 2007. I might have the date wrong, but 2007. So really interesting. And you can see I have total launches. That's lifetime since, you see on Russia down there, Soyuz. I can never pronounce it. My Brooklyn accent comes out. Forget about it. But that's how Americans would get to space, through a Russian rocket up to the International Space Station. So pretty interesting. And what's happened is with the reusable rockets that SpaceX has built, the price per launch, and they actually measure it by price per kilogram to launch a payload, has come down like 1,000-fold. And there's, I don't know if you follow SpaceX at all, but their Starship is almost 100 times more volume for payload than what they do today. So once that thing becomes reusable again, just like the Falcon 9 is, they are going to bring down the cost of getting things to space astronomically. Again, another pun. I can't help it, sorry. So we've been, VMware and us have been working with Starlink. You know, what's really interesting is Keyshawn's talking about software-defined edge and where SD-WAN is going. Each one of these satellites today, and I got to go visit Starlink and see where these things were made, they're actually software-defined edge. If you think about it, that's where they're going. And the whole industry, it's weird how it's all coming together so quickly. I mentioned the latency earlier. This was pretty huge. So SpaceX, and you know, we work very closely with Starlink, but Elon actually called his team, called a meeting on not New Year's Eve, Christmas Eve, and the next morning had a bunch of meetings, and he, as he was home for Christmas, he was reading his books and saying, you know, physics and my math calculations say the latency should be 12 milliseconds for us, not 50. He's like, I'll give you an 8 millisecond buffer, and you have until March. They didn't hit it in March, they hit it in June. So they got down below. The median latency for all Starlink communications today, end to end, is less than fixed wireless access. So pretty huge. But once again, the jitter is what we worry about, and the jitter is what affects our real-time communications. And with, you know, the software-defined edge and the gateway, that overlay makes all that stuff go away for all applications. I just wanted to show this quick schematic because this is kind of how it works. I mentioned earlier that, you know, those satellites go by in 90 seconds. What happens is the satellites up top, they have built the most massive interconnected backbone that you can imagine. It's really free space optics is what it is. It's lasers. So the amount of information, actually you can go, there's a couple of websites you can go to and look at how much information is actually sent satellite to satellite during the day. So your phased array antenna that you deploy from Starlink has one frequency going up to the satellites, and there's a different frequency coming down to the Earth stations. But to stay on a particular Earth station and a particular internet pop, those satellites will, as it's leaving over the horizon, it'll send back to another satellite to get to a better Earth station. So what they did was very smart. They used a frequency on the downlink to your home or your business that is more impervious to atmospheric conditions. And then they used the other frequency for bandwidth that's more apt to have issues with atmospheric conditions on the Earth station side, so that they can transfer stuff between satellites. You know, I can't go to New York because there's a hurricane, let's send it to Ohio. And that's how it gets back to the network. So it's like what we've built as carriers, and they've done it in like 3 years. Pretty cool. So some real world use cases. I had to block out the name of this company, but I'm sure you guys know who it is. This was just recently, at the end of May, there was a bunch of tornadoes ripped through Oklahoma and Texas. And this is one of the, one of those big gas stations that serves great sandwiches and lots of good food. They were the only building standing in the town. We have, there are about 1,500 locations, all SD-WAN with us today, all fixed wireless access, and we had just started doing Starlink with them. They were one of the ones that didn't really believe us, so we had a couple out there with them. And what happened was one of them was 2.5 hours away from this store. They went down there, they got in their car, they drove it down to this location, because I'm sure figured out who the company is, but they're not public, they're family owned still, and they are very community focused. So they wanted to be the only store up to help people make phone calls, get internet access, get food, get water, get supplies. We were able to get them up in 2.5 hours because of the SD Edge and the fact that we could get Starlink there. Our fixed wireless access was not working because all the towers were gone. So pretty cool use case. Another use case, this customer's FIS. I don't know if you're familiar with them. They're the largest financial services company in the world. We've actually built a whole bespoke SD-WAN network with them. So their own gateways, their own VCOs. We extended it into their data centers as well. We co-manage that network with them. They sell it to their banks as a service. So they do a lot of other banking applications as well. And they figured out that the overlay is the most important, right? None of my apps work if I don't have that overlay working. So he's actually on stage. This gentleman's on stage with myself and Sanjay tomorrow, I think at 1. And when I talked about our single SIM, this kind of ties in a whole bunch of things that Keyshawn had talked about earlier. So we have a mobile core that we've built, and we have this actually in the back. It's luggage, and we actually have the Starlink antenna as well. So this basically is a 5G or LTE EPC private core in a box, using not only TCP for our backbone to host for our HSS, but ECS inside the box to actually house the containers for the containers and the ESX. So this is private 5G CBRS in a box up. You connect in the Starlink as long as you have power, and we're right now looking at batteries that we can provide with this. But you could turn this up within 15 minutes. I'm seeing 8 minutes from my smart guys in the back room. So this was actually, it was built in conjunction with the 5G Open Innovation Lab. I don't know if you guys are familiar with them. And we found it because we have a federal agency that works in very remote locations, like by borders, and hands out devices to folks that come in. And they couldn't get service from any of the carriers, and they were having problems activating these things. And this is what we're going to deploy for that. So they have our single SIM today in those devices. It'll be our single SIM with our Mettel private 5G CBRS and the other carriers, so when they leave, they can roam. So this incorporates not only the VMware side, the SD Edge side, and ECS that Sanjay has been talking about. So we call it the Blueberry now. It's going to have a better name, but we had to follow soda and the cookie. And then one last thing. I mentioned that we've taken all the information from the VCO or VECO, and that's how we started to build our intelligent process automation engine. We've carried that on to build a nice overlay where, all these, I'll call them EMSs, are great at getting information about singular sites, but when you want an executive overview across all these, believe it or not, when Keyshawn asked me to talk about fixed wireless access and Starlink and SD-WAN, these are the first 3 things we put together in our executive overview. So we built this really nice data lake and normalized all that information and provided as an executive overview. So the fact that we have all this information, the VECO has all that information, is super powerful. So I think that is all mine, right? Yeah. Thank you.
Perfect. It's great. Thank you. So while he did all the talking for most part, and he came out like the smart one, I should take some credit. So you see who I found for the session? I thought he's the best person right? It's really amazing set of knowledge. So I always am fascinated when I listen to Ed speak. But now you're stuck with me now for the rest of the 15 minutes we have. So a couple of things, right? So I just want to build on what Ed basically said in terms of, yes, the satellite market is vastly growing. And here's some data points, there's a proof points over there, and we see that everything from just from a business angle, how much the industry, the satellite industry itself is expected to grow within less than 10 years, right? By 2032, we're looking at more than $500 billion of just opportunity with satellite. Fixed wireless itself, we see it's going to grow to 6 billion. And again, when you talk about fixed wireless, we're more focused on enterprise use cases and less on the consumer use cases. If you include consumer, I think that's a few hundred billion right there. But there are a few things. When you look at these wireless technologies as a whole, there's a set of expectations that's there with customers. They want it to work very similar to how a wired network itself would work. So all those things written at the bottom are pretty much what you would expect from any sort of connectivity, right? You want assured application delivery. We want to ensure that you can go and deploy these sites just like how you would with the wired. In fact, some of the benefits of going wireless is you just can plop a box and with fixed wireless, you have connectivity up and running within hours. I was looking at a research poll the other day that somebody had done, and there was a bunch of questions asked back to the audience in terms of how long do you think it's going to take for somebody to set up wireless. The choices were anything from few months down to a few seconds, and most people chose, I don't know if it was rigged, but few months. And the answer was, it was 2 to 3 hours, right? So we see all of that. So the other thing, what I wanted to layer on is, yes, we've got all of these. We understand the market, we see it's growing very well, and Ed kind of alluded to data points throughout his session in terms of what is the key thing that really impacts user experience. Latency to some effect, but maybe you can overcome that, but you also mentioned jitter a few times. And as you know from VeloCloud, that's one of our key differentiators, how we can overcome some of those network impediments. Right? So we can address anything from the underlying impediments that the underlying link might have, but all the way from just making it an experience similar to what VeloCloud does for any type of link, all the way from provisioning down to monitoring and troubleshooting. We have a device that is basically coming out very soon. So this is expected by October. So this is called the 710 5G. So this integrates the 5G modem within the device itself. So now you don't have to put in external devices or USBs or Ethernet-based solutions. You can just deploy the 710 5G, and you have both not only wired services to the ports that we have, but also the wireless 5G service. That's the basis of which you run fixed wireless. You obviously can deploy satellite connectivity to this device, but like how Ed showed in those pictures, you need to run your own antennas and then run the cables down and then connect it to this device. What is important over here is, other than the fact that the device exists or will exist very soon and can do all of this, is again the other data point, very similar to, again, going back to what Ed showed, is looking at the underlay links in itself. And that's data from one of our employees who lives in a remote location, and the only connectivity to that site is through either a satellite and a 5G service. So that data is pulled out of our orchestrator. So I just wanted to again illustrate the point with VeloCloud, the differentiation that we basically bring in. I would joke saying that I wish there was some streaks of yellow in the overlay so people kind of believe that this is real data and it's not fudged, but that's the data we got back from the orchestrator itself. The other thing that we did a bit of research itself, just the amount of connections that we see connected into our infrastructure, we started looking at slicing that data, and this is what we came up with. Predominantly, yes, today it's 4G LTE, but there's also 5G that's connected into our network. But when you look at what DMPO, Dynamic Multipath Optimization, brings, the differentiation of VeloCloud, we've seen a significant improvement in the amount of available bandwidth that we see for real-time traffic. So on the left-hand side, you see that for 5G and 4G and 5G services. And you see that anywhere from 60 to 90% improvement, just depending on whether it's voice or video. So that shows the effectiveness of DMPO, without which you wouldn't be able to send that application over that link. And that's what it's highlighting. Very similar when we looked at the connectivity to our infrastructure, and we essentially saw, particularly for video, this is massive. We just went triple digits, right? So made almost all links which were unusable completely usable, and that's what we've seen from the backend and data. We've talked about the 5G device as a whole, but there's nothing that's different as you would expect with any of our platforms. It's all cloud-based. We do support zero-touch deployments, with these platforms. The only thing that, given that we have an integrated modem, and in today's world, we're also used to the concept of eSIM, that's the same concept that's extended to the devices itself. And there are a lot of benefits as a carrier. You don't have to track, SIMs, the IMEI numbers, to which particular customer is it going, what happens in case of an RMA, who's going to even stage this. So you eliminate all of that with the use of eSIM, and that's what we've built within the product. But I think everything else is straight out of the box what we do with VeloCloud. Right. This is important. As you've seen, this is not the first, second, or third, but sixth consecutive time we've been named in the Leaders Quadrant with Gartner. And then you couple this with what Ed was showing, with Medtel themselves being in a fourth-time leader, is where we really feel that the solution that is offered jointly is going to it's going to be very valuable. Okay, which is pretty much what the first point over there was. And lastly, to wrap it up, again, as a joint partnership, it's not just the technology that we provide as an individual company. It's also the experience that you get together. And I just wanted to highlight that as well. Anything that you would like to add before we wrap up? And that's the last slide.
No, thank you.
Okay, I think that's it. We wanted to see if we leave time for Q&A. And if there's any questions, feel free to reach out to Ed, myself, and so forth. All right? Again, thank you so much for joining us. And please, yeah, go ahead.
So, Ed, I have an interesting question. Have you done any dark sites with broadcast-only satellite networks?
I'm sorry?
Have you done any dark sites with broadcast-only satellite networks, broadcast data?
No. No, we haven't. No, it's interesting, though.
There is no.
Mic. I think he's asking you to use the mic if you want. Okay. All right. Thank you so much for your time. Really appreciate you joining us today, and enjoy the rest of the show. Thank you.
Thank you, everyone.
Yeah.